Are you still familiar with the term average? Or do you still remember how to compute your general average on your report card during your junior high? For today, we are going to illustrate, calculate, and interpret the mean of a random variable. And also, we are going to solve problems involving the mean of a probability distribution. Good morning, everyone. This is Teacher Jorel, and welcome to our online class. This data is taken from our previous experiment number 2, wherein we have two boxes, A and B, and each box contains 4 balls with numbers 1, 2, 3, and 4. And in that experiment, we are going to pick one ball from each of the box, and then we are going to get the sum. We listed all the possible outcomes of that experiment. Our random variable S is the sum of those two balls. The possible values are 2, 3, 4, 5, 6, 7, 8. You can see it on this first column. And then, we computed the individual probabilities of the possible outcomes. 1 over 16 is the probability of 2, 2 over 16 of 3, 3 over 16, 4, 4 over 16, 5, 3 over 16, 6, 2 over 16, 7, and the probability of 8 is 1 over 16. And now I added one more column to our table, and I am going to label it S times P of S. What we are going to do here is we are going to multiply the S column to our P of S column. And we're going to write it in this column. Let us begin. The first is 2 times 1 over 16 equals 1 over 8. Next, 3 times 2 over 16 equals 3 over 8. Next, 4 times 3 over 16 equals 3/4. Next, 5 times 4 over 16 equals 5/4. Next, 6 times 3 over 16 equals 9/8. Next, 7 times 2 over 16 equals 7/8. And last, 8 times 1 over 16 is equal to 1/2. After we multiply all our possible values with its corresponding probability, we are going to add all the products. 1/8 plus 3/8 plus 3/4 plus 5/4 plus 9/8 plus 7/8 plus 1/2 equals 5. 5 here is located here. 5 is the average or the expected value of this probability distribution. By definition, if x is a random variable with possible values x sub 1, x sub 2, x sub 3, up to x sub n with its corresponding probabilities f of x sub 1, f of x sub 2, f of x sub 3, up to f of x sub n respectively, then the mean or the expected value of our random variable x is given by the formula E of x is equal to the summation of the product between x and f of x. Let us solve for the mean of this given probability distribution. Our x values are 3, 6, 8, and 10. And its corresponding probabilities are 0.15, 0.35, 0.4, and 0.10. On the third column, we are going to write the product between our x values and its corresponding probabilities. Let us begin. 3 times 0.15 is equal to 0.45. Next, 6 times 0.35 is equal to 2.10. Next, 8 times 0.40 is equal to 3.20. And last, 10 times 0.10 is equal to 1. After multiplying our x values with its corresponding probabilities, we are going to add all the products. 0.45 plus 2.10 plus 3.2 plus 1 is equal to 6.75. Roughly, you will find it here. 6.75 is the average, the expected value, or the mean of our probability distribution. Example number 2. The probabilities that a customer will buy 1, 2, 3, 4, or 5 items in Masagana grocery store are 3/10, 1/10, 1/10, 2/10, and 3/10, respectively. What is the average number of items that a customer will buy in Masagana grocery store? First, let us identify the given. 1, 2, 3, 4, or 5 are the values of our x, and we're going to write it here. 1, 2, 3, 4, 5. Next, 3/10, 1/10, 1/10, 2/10, and 3/10 are our probabilities, respectively. And we're going to write it here. 3/10, 1/10, 1/10, 2/10, and 3/10. Next, on our third column, we are going to multiply the values of our x with its respective probabilities. Let us begin. 1 times 3 over 10 is equal to 3 over 10. 2 times 1 over 10 is equal to 1/5. 3 times 1 over 10 equals 3 over 10. 4 times 2 over 10 equals 4/5. Last, 5 times 3 over 10 equals 3 over 2. After multiplying our x values with its probabilities, we are going to add all the products. 3/10 plus 1/5 plus 3/10 plus 4/5 plus 3/2 equals 31 over 10, or 3.1. 3.1 is the average, the mean, or the expected value of our distribution table. But what does 3.1 means? It means that the customer will buy an average of 3.1 items in Masagana grocery store every time they visit. Example number 3. The probabilities that Dr. Santos operates on 2, 3, 4, 5, or 6 patients in a day are 0.35, 0.25, 0.20, 0.15, and 0.05 respectively. Find the average number of patients that Dr. Santos operates in a day. First, let us determine the given. 2, 3, 4, 5, and 6 are the values of our x. We're going to write them here. 2, 3, 4, 5, and 6. Next, 0.35, 0.25, 0.20, 0.15, and 0.05 are the probabilities of these x values. We're going to write them here respectively. This is 0.35, 0.25, 0.20, 0.15, and 0.05. Next, we are going to multiply the values of our x with their corresponding probabilities, and we're going to put it on the third column. Let us begin. 2 times 0.35 is equal to 0.70. 3 times 0.25 is equal to 0.75. 4 times 0.20 is equal to 0.80. 5 times 0.15 is equal to 0.75. And last, 6 times 0.05 is equal to 0.30. After multiplying x with p of x, we are going to add all the products. 0.70 plus 0.75 plus 0.80 plus 0.75 plus 0.30 is equal to 3.33. The mean of this distribution is 3.33. But what does it mean? It means Dr. Santos operates on 3.33 number of patients in a day. Example number 4. The probabilities of a machine manufacturing 1, 2, 3, 4, 5, or 6 defective parts in one day are 0.8, 0.15, 0.02, 0.025, 0.002, and 0.003 respectively. What is the average number of defective parts that the machine manufactures in a day? First, let us identify the given. 1, 2, 3, 4, 5, and 6 are the values of our x. We're going to write it here. 1, 2, 3, 4, 5, and 6. Next, 0.8, 0.15, 0.02, 0.025, 0.002, and 0.003 are the probabilities. We're going to write it here. 0.8, 0.15, 0.02, 0.025, 0.002, and 0.003. Next, we are going to multiply the values of our x to the values of our p of x. And we're going to write it here. 1 times 0.80 is equal to 0.80. 2 times 0.15 is equal to 0.30. 3 times 0.02 is equal to 0.06. 4 times 0.025 is equal to 0.10. 5 times 0.002 is equal to 0.01. 6 times 0.003 is equal to 0.018. After multiplying our x with our p of x, we are going to add all the products. 0.80 plus 0.3 plus 0.6 plus 0.10 plus 0.01 plus 0.018 equals 1.288 or 1.29. The mean of our distribution is 1.29. What does it mean with respect to our problem? It means that the machine manufactures an average of 1.29 defective parts in a day.